Welcome to BDB Platform Demo. BDB is an end-to-end AI in advanced analytics platform. So today, the agenda of the video is to cover the demo of sentiment analysis of tweets using BDB Predictive Workbench through Neural Network Workspace. And this workflow is beneficial for all those, first of all, a beginner or a learner who has just taken a step towards deep learning, or any business user who is having a complex problem statement regarding his business. So all these people can go on and learn how to create their own neural network, train them and implement them for their business use case and see the results. The motive is to make a user understand here how easy and convenient it is to create a neural network model, to train or retrain those models for utilization purpose through BDB Predictive's Workbench Neural Network Workspace. So let's go on and see how we can create a new model from scratch and then implement sentiment analysis through it. We go into the welcome screen of BDB Decision Platform, continue, and as we continue we are logged inside the platform. In the apps menu we see the Predictive Workbench. So as I click into Predictive Workbench, to give you an overview that BDB has a very robust Predictive Workbench in which we support 5 kinds of integration as of now, listed as R, Spark ML, Python, Java and Neural Network. So these are independent workspace in which any user can go on, make new workflows and implement it. For today's demo, we'll be exploring Neural Network Workspace. Here when we click inside the Neural Network Workbench, in the left space panel you can see all the different components. So this workflow is based upon TensorFlow backend and Keras high-level API in Python environment. These are some of the components for data source, for pre-packaged model, neural network model, custom Python script, model training, apply model, data writer that comes inside this workbench. So today we'll be analyzing sentiment analysis model that is based upon RNN LSTM model architecture. So before we start, I would like to explain that there are 3 steps of doing sentiment analysis that we will be doing in the way. First of all, to create a new model. Second step would be preparing data for that model which can be useful for model training. And third would be the model training. So once these 3 steps are completed successfully, the trained neural network model will be available to use for the prediction purpose, which would be here. So as we go and create, it would come here under the saved neural network model. Now we are going to create a new model. So we go here and create new model and give a name and save it. So as we created, it is listed down under saved neural network model. To view the details regarding any model, either double click on the model or right click on the view model. So we just go on and see the properties of that particular model. Here we show the various details regarding the model, like general details. To give you a better view, this is general details about the model. This is supporting files. So whatever files are being created in data prep steps will be listed down here. The shape of the file, file description. The next is a summary in which the model summary will be shown. Similarly for model script, model status, and summary, model script and model status is shown for recent model training. So whatever model training is going on, you would be able to see the summary, the script, the status of that particular model. Now next is we have TensorBoard. So TensorBoard is useful for live tracking during or after the model training. So we have already created a neural network model as now demo X, and we'll be going towards our next step. So first step, creating a model, is done. We go to the next step, which is preparing the data for that model. So for preparing the data, you can input the data from different sources. Now we go on and create a workflow. So there are different sources where you can go on and create the input data. So for CSV, data service or data store reader. We'll go with the data service. So I have to configure this data service. Now for this data service, I would be choosing one connector which I have already created in the previous steps. So my data connector is available as the name NN, and similarly my data service is NN data. So it has taken in fields that there are two columns, which is text and sentiments. Data type is string. So it is basically taking the tweets over which we'll be doing the sentiment analysis. Also, I would like to mention the text is the one which is having the textual data to create logical data, and sentiment is having three class output, that is positive, negative, neutral data, which will be useful for creating label data for training purpose. So now to create supporting data for model training, we need to use NumPy scripts within the workflow. So we'll use our predefined NumPy script, which are integrization process script and label data creation script. Here under the prepackaged models, we would find all those scripts inside sentiment analysis model. So these are the predefined scripts that are available. You can take reference from these scripts for taking new NumPy script, which will prepare the data for your kind of neural network model. Either you can copy the script in the model and utilize the workflow, or you can just drag and drop. So if I show you the script, we would go and see the script. This is the script editor. So what you can do is to create your own script, you can either copy it and edit it or take a reference from it. Once you're done making a script, you can go on and just drag and drop that particular component. So as per today's demo, we are going to take two different scripts. So let me connect integrization process script and label data creation script. So I will just drag and drop these both into the console. Now I would quickly configure it after joining these. The first component is our integrization process script. This is a NumPy script which will take in the text column and will convert the textual data into numeric array that will create the logical data. So we will give our demo name. The output NumPy file can be given as logic data, as it is creating the logic data for us. You can give an optional description. So as it is bringing the logic data for us, you would provide the description as logic data. Select the column header. So this first will be bringing the text. We would apply this, and then we would go to the next component. The next component is your label data creation script, and we would configure it. We would select the model name, which has just been given. As it is providing us the label data, we would give the name as label data X regarding our model. Here the description is optional, but it is better to give because this will be useful when you are having lots of supporting files, and after some time it can acknowledge that what kind of data one file is holding. So as it is labeled data, we are basically having a script in our categorical column which is having three output classes. So we will select the model name here given the NumPy file name description, and the column header would be sentiments and number of output classes would be 3. So we would apply this model. As it is applied successfully, to avoid any loose ends, we would save this workflow as save demo X, and and this is saved successfully, and we would run it. Once we run this workflow, the supporting files will be created for respected workflows. In the console, you can see that all the components action are executed successfully. So let's move on to the neural network model and view its details that we have created for this particular workflow. So here is the demo X. We would view the model. As you can see that under supporting files, two new files have been created, logic data and the label data, and you can see the shape of the file in the description as well. Here preparation of data is completed, which was our second step. Note that based upon your neural network, preparing the model data can take more than 2 scripts as well. Here we have taken just 2 scripts. Moving towards our final steps, that is model training. Click on the model training. So here we have model training. In the model training, you have to provide 3 kinds of info: general, model structure, and model training. Now first we'll go for the model selection. So select the model which you have to train. This is our model which we want to train. Retrain model. If you want to retrain the existing model, you can opt yes. And for creating a model structure, I can choose UI or script editor. Here, as the model is already under training, it cannot be trained, and UI for model structuring is just a support. So we would go for user interface and go for the next. Here is the UI for creating a model structure, which is shown on screen. We are providing most useful Keras layers for structuring our model. You can see here on the right side, core layers, convolutional layers, pooling layers. There are so many layers that we are providing. And then inside these layers are the sub layers. So these are the main categories of Keras layers which are configurable through UI. You can click on any category and that will expand it and show you its sub layers falling into that category. So in core layers we have these many sub layers: convolution layers, pooling layers, locally connected layers, recurrent layers, embedding layers, advanced activation layers, normalization layers, and noise layers. As we're creating a sentiment analysis model, we'll create our layers accordingly. So we would go and choose one embedding layer. You just drag and drop it to the console. Here, on clicking onto this component of embedding layer, you'll see the configuration box, and there are some default values that are already been set, and just we can feed in as per our requirement. So for my input dimension, I am feeding some value. For output, it's 128, and input length, I'm taking it 140. As I give my configuration, I can apply. So this layer is configured. Next will be our LSTM layer. So I would drag and drop the LSTM layer, connect it with the embedding layer, and click on it to configure it. I see so many configurations here. So the units would be 32. And as we're supporting a sequential model, so here we put the return sequence as true and apply it. Same, we provide another LSTM layer and do almost the same configuration, but in this particular LSTM layer we would make a change, put the units as 32, and there is a configuration related to the dropout, which is the recent dropout. So we are putting it as 0.4 and then return sequence to be true and apply this layer. Then after that we will go to the core layers. In the core layers we have flatten layer, dense layer, activation layer, and dropout layer. So we would take one flatten layer, connect it and apply it, and then we would drag two dense layers. This configuration of layers depends upon model to model and the need to need. So for this particular layer, we would put on some configuration. For units, I'm putting 32, and activation is rectilinear, and apply it. Then I connect it to another dense layer, and for units, I would put 3, and activation to be softmax. Here I would need to put the unit layer for 512. Right. So this is the layer configuration that I have done, and you can remove any layer or connection to restore the configuration. So if I want to remove a particular connection, I can remove it. I can remove a layer node as well. So all these configurations are possible through this UI. Now before we go to the next step, let me briefly explain you this model. So our prepared data will feed into embedding layer, which will create vectors. These vectors will be having 3D shapes, and output of these vectors will be fed into LSTM layer. Now, which will map out the words or sentiments, calculate their distance, etc. The same will be done in the next LSTM layer, and we'll be flattening the input using the flatten layer. Now there is a dense layer which acts as a hidden layer that will memorize the data totally based on what number of units we are providing here in the dense layers. So according to the given input, it will memorize. If the given input is more, then it would memorize properly. If it is less, then it won't memorize much. And if it is perfectly accurate, then it will train the neurons of this model. So that's how it works. And in the last one also we have put one more dense layer. So the last one is also a dense layer, which is called the logic layer. So as our own number of output classes is 3, so we are providing units as 3, and activation is softmax here. Apply it. As we go to the next step, we see that there is an auto created script in script editor panel based upon your recent configuration of the layers. So as we have mentioned earlier, that our UI is just a support because our layer from Keras couldn't be configured using UI. You can add more number of layers as per you need here. So in the last, you have to modify this compile method based upon your neural network requirement. As our output class number is more than 2, here it is putting binary, so we have to change it to categorical cross entropy. I would delete binary and put categorical cross entropy. The optimizer is NADM here, and metrics is accuracy. You can configure them as well. Once you have done your desired configurations and changes in the script, you can validate it. And Python script has been validated successfully. Now you can go to the next step. The next step is the model training. Here we have to provide the parameters per fit method of the model. Whatever supporting files we have created has been listed down here. If we choose the logic data file, so for that particular model it's logic data x, and label file as label data x, we would enter the batch size as 32. So provide batch size, which is batch size for that particular part. For each epoch value, it means how many epochs do we wish to train this model. So let's suppose we would put 20, and you can also perform validation split. So validation is splitting your data into training and testing, so that the test part will be validated against trained model after each epoch. Now if I enter validation split value as 0.1, which would mean that 10% of the data would be tested against the rest of the trained data. You can choose the shuffling as true or false. So shuffling basically means shuffling between training data during various epochs. You can also enable the email notifications. So once you enable the email notification, you can enter the email address on which you would want to receive the notifications regarding this model training. BDB.ai. You can choose different options for that, as it is a time consuming process. You would receive a notification as soon as your model is trained, so you can check out what is the status and how it has been trained. Now we would start the model training. It says, do you wish to start model training? And you should make a note that once model training is started, you will not be able to reconfigure the training parameters. So make sure before this step all the parameters are right. We will choose yes. Please check for status of the model. Now we would go back to our tensor board to see the live tracking of the model training. This was our model for which we would wish to see the details. Here it has listed down the supporting files. Firstly, we would see the summary. So as there is no summary available, we would go to the model status, refresh it, and as soon as we refresh it, it starts giving us the values of the different epochs. What is the validation loss, what is the validation accuracy, loss or accuracy in general. You can also stop the training in between if you're not satisfied with the training. As soon as you refresh again, you would see the epochs adding and status of the model training. You can go on and see the model script, which we have scripted using the script editor or UI, whatever the method is. And then you can also see the summary, in which you can see the different type of layers, their output shape, and what is the total parameters, trainable parameters, all this kind of summary regarding one layer or a model you can see here. Now the interesting part is the tensor board, where you can go and check the live accuracy graph with different dimension. You can change the smoothing, or you can check the different values, the relative wall, etc. This is the loss, this is for validation accuracy, and this is for validation loss. And now we go back to the model status, and we would wish to see when all our epochs are done. So we have put the epoch value as 20, and as we refresh the status, you would see it's on the last epoch. Now it has completed the model training, and we would go and put this model into our predictive workflow to do the sentiment analysis now. Let's create a workflow. For creating a workflow, we'd start with the data source. So we take a data service as the input, in which we have the sentiments and text as a column, and we would configure it quickly. So to configure it, just click and choose the data connector that has been created for this particular service, and we choose the data service and apply it. Now we would choose the neural network model that we have recently created, the train model. Just drag here, click on it, and here you can see the summary, supporting files, etc. Apply the model properties onto it. Now we know that during our data preparation, we used one NumPy script that transformed textual data into numeric format, over which our model has been trained. So for predicting via this model, we would have to do the same. So we'll be using a script that would convert the data into model understandable format. For that, we already have that script as integerization process script for workflow. So we would just drag the script, connect it with the data service component and configure it. In the configuration part, we would select the column header as text and apply it. Now next comes to apply this model over the input data that we have taken in data service and being converted. We have to choose a component which is called neural network apply model component, that is in component. So we would connect this with the train model and the input data. Here we have to select the column header, or if we go on this particular component and choose the advanced category, so we have to select the column header which is having numeric array over which the train model will be applied and the probabilities of the classes will be calculated. So we have transformed a numeric array as an output, so we select this numpy output, which is the output that we have created, and apply it. So at this point of time, we'll get the probabilities of each of the classes for which the input data under which it can be fall, but this can be numeric as well. So whatever output is coming would be having different probabilities because of this component. So for that, we would be using another script. Using this output script for workflow, we'll convert the probabilities that are coming here into classes, into one definite class, whether it be positive, negative or neutral. Now we would feed this output into the output component, and that would be our numpy output, and apply it. Now all these predefined scripts can be modified as well as based upon your neural network model requirements. So we can save this output into any particular data writer. So for that we have three choices like data store writer, file writer, database writer. So we would just choose data store writer and write this output into a data store. We could click on it and in properties you can create a new data store, give some name to the data store, click on the next and apply it. So as we have made this workflow, we can run it instantly. So here you can see the progress bar and all these scripts and components in action. Now regarding this particular data store writer, which we have written in a particular data store, this creates a elastic store index. Through this index we can also create a business story as well using this index number. So we would like to understand this result of each component. So firstly, the data service component in which we were taking the input data. In the result tab, we can see that there is a text and sentiment column. So these two columns. Then we go to the next script component and see the result. So this script is turning it into a numpy output. So this is our numpy output for each component. To have a better look, you can have a look like this. For this particular sentiment, this is the numpy output, and this one. So we go to the next component and see the result of apply model. So the result of apply model component is the probabilities of the number of output classes under which the output classes can fall. So basically to say is, as we have three classes, that is positive, negative and neutral, so it is showing us three probabilities for them. After that, this component would actually give you a definite class out of those three probabilities which the apply model has generated. So in the result tab, you can see that predicted result is positive. So that is deciding on the basis of three different probabilities that what should be the the exact one or the one we wish to see. So on the basis of these probabilities, it is giving the script is giving a definite class in terms of predicted result or predicted output. From here, we can write our output to a data store as we are using a Elasticsearch here, and then we can generate, as I already mentioned, a Elasticsearch index that could be later used in the other modules of BDB platform, or one of them could be business story, where a user can create his own reports and business story using that. So here, that is a demo of how we can do the sentiment analysis of the tweets using the BDB Predictive Workbench and the neural network workspace. Thank you.